All right. Very good morning to one and all. Thank you so much for being here in person and also for those who are joining us through the stream virtually. This workshop session here is part of the networking working group, and we are going to expand upon one of the product announcements that was made at the keynote yesterday by Meta. More specifically, the Wedge400 top-of-rack switch. Now, before I go into that, let me first introduce myself. My name is Vignesh Vijayanath. I'm a technical program manager at Meta, leading product development efforts in the networking space. I'm also joined by my colleague, Lingjun Wu, who is the hardware engineering lead on this product, and Johnson Liu, the engineering director from Celestica, our valued ODM partner on this project. Okay. Go ahead. Yeah. All right. To start off with, I want to talk about some of the motivations we had in building this product. To take a little bit of a recap from the keynote, if you had noticed, one of our latest contributions on the top-of-rack solution space was back in 2017, which was the Wedge400S solution. It was basically a refresh of the Wedge400, which was released in 2015. It had an upgraded CPU subsystem, and it had a few security features added onto it as well. But essentially, the Wedge400 has been our staple top-of-rack switch solution for quite a long time. It has sustained a lot for compute and storage platforms over the years. However, as you would already expect, the growth is exponential. So our compute platforms are now looking forward to increased adoption of 100 gig NICs. In addition to that, the rise of AI/ML platforms and their rapid progressions means that we are starting to hit some of the boundaries that the current switching solution has. Back in 2019, in order to sustain some of this growth and the out-of-rack bandwidth, Meta also introduced the F16 fabric topology solution. And with that, it means you had 16 planes of fabric connectivity from the top of rack as well. So with all of these factors adding in, and serviceability being another top-of-mind item for the team, we looked into a newer solution for a top-of-rack switch. What we ended up with is a 2RU top-of-rack solution, which has 48 ports. It has 32 QSFP-56 ports that could run up to 200 gig. This would support our current generation of platforms, right down all the way down from 25 gig NICs, all the way up to 200 gig NIC solutions. We also have 16 QSFP-DD ports. At Meta, we virtually distinguish them as our uplink ports, and it can run up to 400 gigs at max rate. So this now allows us to be backward compatible with our existing fabrics, fuel our next generation 200 gig fabrics, and also be a viable solution for our next gen 400 gig fabrics in the future. And this slide basically gives us a quick snapshot and the evolution of our ToR solution over the years. In addition to this, there was another announcement that was made at the keynote yesterday, which is a flavor of the Wedge400 with the Cisco ASIC as well. Now, in terms of the product by itself, you can look at it. There are two alternate versions of the ASICs, the Broadcom and the Cisco ASIC. But the SKU in itself will come in two power versions, one with the DC power using our DC power entry module, and one with AC power, PSUs. It will support to be mounted onto a standard 19-inch network rack, as well as the ORV2 21-inch rack. So for that, we also offer the 21-inch ORV2 adapter tray. Now, with this, I'm going to hand it over to Lingjun, who's going to take us through the broader design principles on the product.
Thank you, Vignesh. So my name is Lingjun. I'm the hardware engineer from Meta. And I'm going to describe the details or introduce the details of Wedge400 design a little bit. So this is the box. So you can see it has a 2U space, and also it is designed to adapt to through this ORV2 tray in order to install in our OpenRack V2 rack. And it's running FBOSS software from our side. And also, it has this mini lake, which we contributed last year, I think, or 2 years ago, with a COMI module based on Broadway. And it has a BMC, which is based on A-Speed 2520. And also, we have Tomahawk 3 as a major switching ASIC on this platform. So this is the top view of the switch. So you can see there are many components combined together to build this Wedge400 platform. So as Vignesh mentioned, we have the first row as 400G, also down to 200G and 100G as QSFP-DD form factor. And the bottom two rows are supposed to be downstream ports, and they are designed to be Q56 connector, and can be used for 200G DAC and 100G DAC, or breakout to 2x50G and 4x25G. And the real side, you can see we have 4 fans, and also there is a small latch we can use to plug out the control board, which can be used as a through, so that we can easily replace our CPU-related components. So this is a typical architecture that Meta was using as a switching element. Typically, there's a BMC, there's a microcontroller, and also there's a switching ASIC. And the Wedge400 is the same, following this architecture. So this is a out-of-band connection inside the switch. So we do have a simple layer 2 switching chip to connect to BMC, microserver, and the front panel RJ45 connectors. So once the management cable is connected through this RJ45 connector, both BMC and microserver will be connected to the management network. So this page describes the PCIe assignment. So the Wedge400 system has multiple PCIe devices. So switching ASIC is the major one, and we are also using NVMe SSD, which is connected to the PCIe. And there are 2 FPGAs which supposed to work as a controller to access the optic modules through the I2C controllers. There are multiple I2C controllers designed in the DOM FPGA. So we have 2 because the left side one handles the left portion of the ports, and the right one handles the right side of the portion of the optic modules. And this is the UART and rack mount connection. So the UART on the front panel, RJ45 is directly connected to BMC, and we also have a CPRD to max and demux, do the selection of the UART connection between microserver, and also we have a OCP debug card, which has a UART locally for debugging purpose. And the rack mount is also a major feature that used on our ORV2 rack. So it has a new design on Wedge400 comparing with Wedge100. So it is using USB controller, and there is a USB mux between microserver and BMC, so that there is a flexibility of selecting or using BMC or microserver to drive or to control the rack mount. And there's a FTDI component to convert to the UART. And this is the SPI diagram for Wedge400. So there are multiple components like flashes, and like the the switching ASIC PCIe firmware need to be stored in the flash, and we have FPGA with image in the flash, and also some of the other components, minor components, need flash. So we go through the CPRD to control all the SPI interfaces in order to upgrade them from BMC side. Yeah, on Wedge400, we also introduced a module called the BCM Storage Module. So the reason is that we have some security requirement to easily access all the storage parts. So we introduced this M.2 form factor, and it is located on the SCM control card, which is a through, so we can easily plug out the SCM card and to access the BSM module. And the components on this BSM module mainly contains the BMC's flash primary and secondary, and the eMMC. Also, we put an eScorpium there to record the serial number and track this component. Yeah, we also did some power measurement as a reference. So we have multiple types of rack configurations. And this picked some of the 50G and 100G downlink, and with 8 uplinks or 4 uplinks as a typical configuration. So you can see the power consumption is around like 250 watts, and even with 100G maximal configuration for the downlinks, the power consumption is still within 300 watts. Yeah, with this, I'm going to hand over back to Vignesh for use case. Thank you.
Thank you, Lingjun. So typically when we do contribute our products to OCP, we do make sure that we have some mileage in deploying these in our data centers. So this has been deployed in our data center for over the past 1 year, and it has also been used for supporting the rise of our AI/ML platforms, both in training as well as inference. This was critical for us to kind of release our first inference platform late last year, and as well as our AI training platform that you probably would have attended the workshop on Xeon EX. That was also released earlier this year. Now, of course, at the keynote, we did mention about Meta's collaboration with our optical vendors, the 200 gig FR4 and the 400 gig FR4 optics. Both of these are qualified on this platform and are being deployed with this platform as well. In addition to that, like I mentioned previously, we are looking at backward compatibility for the platform. So every solution that we have qualified today in our data centers are backward compatible with the Wedge400 platform. That also includes downstream connectivity with DAC and the different breakout configurations we would have with the DAC as well. Right. Now with that, I want to call upon Johnson, our partner, our ODM partner for Celestica, and would like him to share some words with you.
Thanks, Vignesh, and thanks, Lingjun. Very impressive presentation today. You can see this is a pretty simple presentation, but I still remember how much the hard time we had, work together, to get this happen, right? So my name is Johnson Liu from Celestica. Celestica is an OCP server member. We are the leading designer and also the manufacturers for the open platforms for the hyperscalers and enterprise customers, including the networking, storage, and compute products. We are thrilled to work with Meta as a design and also manufacturing partner for Wedge400, which will be part of our open network platform solutions. Oh, sorry, I forgot to change this page. So Celestica worked with Meta for quite a long time already. So Wedge400 is one typical example. Meta defines a product roadmap, and Celestica and Meta work together for the solution and architecture development. And Celestica provided the detailed hardware design, verification, validations, including the electrical design, mechanical, thermal, signal integrity, power integrity, compliance, etc. And also provided low-level software solutions, including like BIOS, OpenBMC, SDK, by working with third-party partners, and also developed the diagnostic softwares to support the design and also manufacturing test. For the product quality, Celestica has a pretty comprehensive management process and also systems and also the test process to cover from the design to the manufacturing, such as the issue management systems, root cause corrective action process, continue improve, continue test process, close loop the test requirement, and also the test cases for the best coverages. We also have the test automation fully implemented for this program to have a best like the test efficiency. The test progress also being fully transparency to enable these two teams can work together seamlessly. So with that, for today's call to action, you can access the OCP contribution page for the Wedge400 design specifications and also the design packages. And you can reach out to Celestica for the detail about the Wedge400 commercial availabilities. So with that, we'll go to the Q&A session.
If you have any questions, please do come over to the mics there. Thank you.
Yeah, thanks for the presentation. You said you've had this in production for, I guess, a little over a year. How much mileage do you have on PAM4 DACs, and what sort of cable lengths? Or is most of your deployment still around NRZ and DAC?
Yeah, thanks for your question. Yeah, so for PAM4, especially for the downlinks, we are running 200G PAM4, 4x50G. So today we do have an application using 2-meter 30 gauge. That is the longest one we are deploying for now. Yeah.
Hi. I was wondering how you partition the front panel ports across the two ITMs inside the Tomahawk 3. It has kind of two ingress traffic managers. And what were your reasons behind those choices?
So this is also a good question, and we do have some consideration regarding the internal memory distribution and also internal resource balancing. So we pick the number like 1, 3, 5, 7, 11, all the way to 15 as our uplink. If there is 8 uplinks, if there is all 16 to be used, then all the ports will be used. And both the uplink and the bottom link are sharing also the resource balanced port mapping.
Is your product compatible with next generation optics, 800 gig or two times 400 gig optics?
Not with 800 gig at this point. For 800 gig, you would need the 100 gig SerDes solution. The Tomahawk 4 SKU that we are currently using is the 50G SerDes solution. So it goes up to QDD with 400 gig operations.
So similar question, but on the optics, you mentioned FR4 is qualified. Is there any limitation, aside from 800 gig, but 400G down, any PMD limitations? Or can any standardized form factor work?
When you say limitations in terms of compatibility?
Like a DR4 or, BIDIs or any of the other transceiver types.
Yeah, I'm not aware of anything. Lingjun, you want to take that?
So we have done lots of SerDes tuning between the optics and the switching ASIC SerDes. And as long as the retimer or the SerDes type on the optic side is similar or with a similar behavior that meets the IEEE standard, I think the risk should be very low. But we mainly focus on FR4, 200 FR4, and the Facebook, the Meta project.
Yeah, for this question, actually, Wedge400 have the power envelope, the thermal cooling envelope, all this defined. So under this envelope, you should be no problem. But if you're beyond that, for example, this will be like a QDD. If you go to up to like 25 watt, probably will be challenge, right? So it cannot be say we can support all the type of optic modules, but under the envelope should be no problem.
When you ported FBOSS to this platform, were you able to use the standard SPI library from the vendor, or were there any learnings and adjustments?
Great question. That's a good segue to our next talk. I think our FBOSS team is going to talk more about how that integration has happened. So if you hold on a little more, I think at 8:25, that talk is going to start. And they are the best folks to give you that answer as well. All right. Thank you very much, everyone. Thank you for the opportunity.